Hey guys, we're gonna do the next topic of this chapter. So we're on the mole unit. We went over molar mass and percent composition so far. We will use molar mass within the next couple of classes, but we're gonna switch our focus into something else, that bringing back what we already learned from the beginning of the year and applying it to the topics that I made you watch a video about last class, the mole. So we're going to go over the mole, go back over the previous stuff from the past chapters that we use that we will apply in this chapter. So it is a different kind of setup of these videos because I'm not allowed in the school to videotape myself teaching at the board. I am now using my whiteboard on my computer, and I'm just going to record my voice over top, and it also records the screen as I kind of write on it. So you can flip to the factor label section of your notes if you are using your notes. If not, you can just title your next piece of paper factor label. We also called this at the beginning of the year dimensional. And sorry, I'm kind of taking some time to get used to writing on this. Dimensional analysis. You can call it either thing, the factor label or dimensional analysis method. This is a method for converting units of measurement into other units. Of measurement. So I think on the previous worksheet, I asked the mole worksheet if you remembered how we would convert from inches to feet or something like that. So this process of converting inches to feet we would do with something like this factor label method. So if you need to pause this video to get this definition, it's a method for converting units of measurement into other units of measurement. And this is going to use equalities or fractions. So in the notes, I wrote this technique uses conversion factors that are made from equalities between units, and the conversion units are arranged in fraction form in such a way as to cancel all other units except the desired units. So an example of this would be 15 inches into feet. You went to Lowe's and you were asked to get a 15-inch board, but they only have measurements of feet. So we would start with that 15 inches and we would put it over 1. You would always start with putting everything over 1, and then you would think back to an equality between inches and feet. If you would take a ruler, there are 12 inches in 1 foot. And you saw equalities with the mole unit or the mole video yesterday. It said 1 mole equals blank atoms or molecules. So we're going to use those equalities just like we did in the past couple units, or it was like at the beginning of the year we did the units of measurement units. So we would then place the 12 inches at the bottom so they could cancel out. We then would have 1 foot on top because 12 inches equals 1 foot. This is our desired unit. They would cancel out, and we would have an answer. If we put it in the calculator, we would multiply across, divide down. Our answer would be 1.25 feet. Sorry, that went off on the past one. These have a 5-minute limit, so I'm going to clip them all together. So if you didn't get that, the answer is 1.25 feet. So 15 inches is actually 1.25 feet. So we are using this again now in this mole unit. You will see what I mean and why I'm teaching you this or bringing this back up, because we will use this in problems that can help us with the next set of problems that we will learn. So another example that is simple that can help you get this back into your brain is time. So how many minutes are in 4 hours? At the beginning of the year, I asked you simple questions like this. So you know that in 1 hour, there is 60 minutes. You are given hours. We're looking for how many minutes there are in 4 hours. So you always start with what is given. And I'll write out a simple way to describe this if you want after. So you always start with what you're given, and you put that over 1. So we are using fractions, and the conversion units are arranged in fraction form in such a way as to cancel all units except the desired units. So we're trying to cancel out hours. So we will place hours at the bottom. And if we look at our conversion up here, 1 hour, so we put 1 hour at the bottom, is equal to 60 minutes. So in this conversion, we will do on our calculator 4 times 60, which is 240. And then if we multiply across the bottom, 1 times 1 is 1. So 240 divided by 1 is simply 240 minutes would be our final answer. So the conversion of how many minutes are in 4 hours, there are 240 minutes in 4 hours. And that can help you in different situations, real life situations. We talked about that before. And we are going to apply now these conversions to molar mass, the mole, and counting atoms in a mole. So we can kind of describe the factor label method as given. It'll always be over 1. And then we will have the given unit on bottom. Given unit. And desired on top. There was also multiple step problems, like if we have hours, we are going to seconds. We will save these for the next. We will use different techniques, or there was another step in between. We will go over an example like that when we have to apply it to an example like that with this unit. So the next topic we will learn is the mole. The next thing we're going to talk about, and we will use these factor label conversions for, is the mole. You learned this from the video that I made you watch the other day. And the mole is a measurement of amount. And that amount can either be atoms, particles, ions, formula units, and molecules. So we will be able to convert moles to things that are atoms, particles, ions, formula units, molecules of a compound. So this measurement, the mole, is an SI unit. We talked about these at the beginning of the year. They are used around the world. So a mole is not just used in the United States, it's used in other places. It's a standard unit of measurement. And you can abbreviate the mole, MOL. I made you guys do molar mass, grams per mole, and I was writing mole without an E. That is why we abbreviated. It's not really an abbreviation because it is only taking one letter off, but it's definitely easier than writing that full E. So the mole is used around the world, and it was found by experimenting with counting atoms of 12 grams of carbon-12. So I made you guys kind of research Avogadro and who he was, and they named this number after Avogadro. So this number that I made you guys kind of hint at yesterday with that video was called Avogadro's number. This will be a key number used in mole conversion. So we will use this number a lot, and this number is really large, but we don't write it as its really large version. We don't say it as its really large version. We kind of break it down. So I asked you on the previous worksheet if you knew what scientific notation was. A lot of you guys said that you learned it at the beginning of the year in math class. I'm not going to make you focus so much on finding scientific notation because you will be able to use a calculator, and there is one conversion that you can use, or there's one number that you need to know. You're going to type that in the calculator, and then you'll get an answer and you'll write it in scientific notation, but you never need to figure out scientific notation. So Avogadro's number, and we will use this in conversions, is that 1 mole is equal to 6.02. Let me erase that one dot. Sorry, guys. 6.02 times 10 to the 23rd power. So that means that there are a lot of zeros in that number. You are moving that decimal place to the right 23 times. So that conversion is 1 mole is equal to 6.02 times 10 to the 23rd atoms, formula units. Sorry, this is so sloppy. Ions and molecules. Why does this do this? You know what? I'm just going to erase this whole part, and I will go over this in the next section. The next 5 minutes. The video stopped in the last time, and I just moved it up. But Avogadro's number is equal to, so that conversion, or Avogadro's number, is really 6.02 times 10 to the 23rd, but it equals 1 mole. So it is 6.02 times 10 to the 23rd of atoms, formula units, ions, or molecules. So there's just different terminology. So if you see any of these things like atoms, formula units, ions, and molecules, it will be in either a question and you'll have to convert it to moles, or it'll be asking you to convert moles to atoms or formula units, ions, or molecules. So this is called a conversion factor, and we will use this a lot in this unit. So just like the video said yesterday, a mole is a measurement of amounts, just like how, and this is explaining the amount of atoms in a mole, just like how a dozen is a example of a measurement of amount. There is 12 donuts in 1 dozen. So it also can be referenced as or is similar to that. So we are going to do conversions with this. So just like how at the beginning of this video I said 1 foot is equal to 12 inches, we're going to use that same method of using dimensional analysis or factor label method and setting up fractions in questions that will ask you to convert moles to molecules or molecules to moles. So I have some examples in the notes that will better explain why these two things are linked together. So I am going to put up a picture on the screen, and there are 2 questions. We're going to start with the easiest questions that we're going to walk through them, and it's very similar to the previous stuff we did this year. One thing that I'm not going to be worried about since we are doing this online is significant figures. We would do that more in class, and maybe we will, like for the test, if we go back to school after Easter. If as we continue through, though, I'm not going to make you worry about that because there is just so much that there's only so much I can do online. So I'm not going to reteach you significant figures when I know I could go over that in a class with you. But I don't know, honestly, if I'm reaching enough to spend a whole hour cycle period when we only have 2 cycles a week. So you're not going to have to worry about significant figures. I want you to still worry about units, though. So in these problems that you will see, I will explain what I mean by what you need to be worried about with units and why you need to be so worried about them. So if you do not have the notes printed out, I want you to pause and write what I have in your note packet or line sheet of paper, what is written on this section. So I rewrote the conversion or Avogadro's number because we are going to use that. I had this kind of put in a bubble before. So I have that written up here, and then some examples with a good key factor before the example. So when completing mole problems, we will use the factor label. I already kind of mentioned that. We will always want to underline what we start with, and we are going to circle what we want to convert to. So we are going to use these conversion units, and they're going to be arranged in fraction form in such a way that all units will cancel out except for what we're trying to figure out. So everything that is going to be circled you will want them in your final answer. So in the first example, and you'll see I have 2 examples, one way and the other way. I'll show you what I mean by that. So the first example says, how many molecules of CH4 are in 5.60 moles of CH4? So if we do these problems kind of like how we started the conversion factors of inches to feet, you're always going to want to start with what you're given, and we're going to circle what we want. So we're starting with moles, and we're going to go to molecules. So we always give our number in our units, or we always write our number in units at the top with a 1 underneath. So we have 5.60 mole of CH4 at the top. And we'll set up another fraction because we know we need to cancel that out because our final unit is going to be in molecules. So we have 5.60 moles of CH4. So at the bottom of our factor label or conversion, we always want to have that same unit at the bottom. So if we're starting with moles, we will have moles at the bottom because that needs to cancel out. So we have moles at the bottom now. in our conversion up at the top of this screen, how can we get from moles to molecules? And I wish you could see me shrugging my hands because I'm wishing you could answer me, but it's not that case. I'm at home, you are sitting in your house or somewhere else. So you have to keep looking back at this conversion. So we are trying to get from moles to molecules. We can use Avogadro's number to get from moles to molecules. So in this conversion, it says that 1 mole is equal to that many molecules. So we will put 1 mole at the bottom because it says that we are starting with 1 mole, and that is equal to 6.02 times 10 to the 23rd molecules. So you can see that using this shorthand math or the scientific notation of Avogadro's number is much easier than writing out 6.060000021 zeros after. So you will just write the scientific notation, and that will be easier also to type in your calculator. So now the next step, we can cancel out our units. We have moles that are canceling. We want to get to molecules. That's what is circled right in this step. And you can see that you will end with molecules. So you can even circle your last unit that you get to make sure that you get to molecules. So now the last step to do is we figured out all of our units cancel. We can open up our calculator and use our calculator to figure out what is 5.60 times 6.02. Okay, so when you type in 5.60 times 6.02 times 10 to the 23rd, I'm pretty sure that you've worked with exponents in math class before. You will need to use on your calculator the caret button. And if you are having trouble using your calculator, please let me know. I just don't know what calculators you guys have at home. There are different calculators you can download as an app that I'll try to look up different things that you can use if you're using your phone. You do have a calculator. You might need to change the orientation on your phone and move it sideways so you can get the exponent button. I'm not sure if it's on the regular calculator that pops up when you just use your phone calculator. Like, you can extend the version of the calculator if you flip your phone over. It becomes a bigger calculator. You might have like a Texas Instrument one at home. I would use that. It is much easier to look at the answer or type in with the exponent caret like I'm talking about. So when I type that in on the calculator, we get an answer of 3.3. This pen is really hard to write with, guys, and I'm sorry that it is looking so messy, but we're going to work with what we get. You get a number of 3.3712 times 10 to the 24th. So I'm going to just round it to the hundredths point as what we were doing. We're not going to worry about sig figs. So our answer is going to be 3.10 to the 24th. And that is not our final answer because that is just a number. Numbers always will have units with them. So our units will be molecules, and those units are not finished. I would circle what compound is with that because it could be molecules of apples, molecules of anything. It's not just molecules of anything, it's molecules of CH4. So that right there would be your final answer for this problem. You started with moles and we converted that to molecules. And this is important because we will then be able to convert moles or moles to grams. We can convert grams to moles, grams to atoms. We're going to get into different examples that go further in our multiple steps, which will help us and what would help us do labs in our real life class. I'm going to try to look up if we can do a virtual lab on the computer. So stay tuned for that. I'm going to do the next example, which is how many moles of sodium are in 6.85 times 10 to the 22nd atoms of sodium. So I'm going to erase so we have more room, but if you didn't get that, pause this. And if you have any questions, please email me or chat me. You will have to do multiple practice problems, but the next example will show you more practice and that we're just really focusing on one-step conversions right now from moles to atoms or atoms to moles. So in the last one, I ended with the word so. I meant so. I just kind of cleaned up the screen that I was working on. I erased all the work. I just rewrote that 1 mole is equal to 6.02 times 10 to the 23rd atoms, formula units, molecules, and ions. So the next question, we are starting with atoms this time instead of moles. So we're starting with atoms instead of moles. We are trying to get to moles of sodium. So we are starting, when the first step of these problems, we will always write out what we are starting with on the top. So we are starting with this number of atoms of sodium over 1. So we're starting with that many atoms. So we should have, to cancel out our units, we will have atoms at the bottom. So if we take a look at the top of our screen, it says 1 mole equals 6.02 times 10 to the 23rd atoms. So we're going to have moles on top now because that is what we are trying to get to. And if we read that conversion factor over and over again, next to the mole, you will have 1 mole, just like in the conversion up here, 1 mole is equal to this many atoms. So we will put that that Avogadro's number, 6.02. I don't know why this is not working. Times 10 to the 23rd. Like, does not want me to write a 2. Twenty-third atoms. That is 6.02 times the 23rd times 10 to the 23rd power. So just know that's what it says. I'm sorry that it's not letting me write that. So we are going to put in our calculator this time something different. Last time we were using multiplication because the 6.02 times 10 to the 23 was at the top. This time, the 6.02 times 10 to the 23rd is at the bottom. So our calculation will now be, if you take your calculator, it'll be 6.85 times 10 to the 22nd. It'll be divided by 6.02 times 10 to the 23rd. And for that answer, I get, with my calculator, 0.113787375. So I'm just going to, again, round that to the the hundredths place. If you round it differently, as long as we're getting the same, like close to answer, I'm not going to take off points. So I'm going to write it down here, 0.11. 1 would be our answer, but our answer includes units. So whatever is circled, and we can figure out if we figured out the right answer by crossing off our units. We have canceled out atoms because we are dividing. That will cancel out the units. And then we are left with moles. So our answer we can check is the same. So we know we did the problem correctly. So we have 0.11 mole of sodium. And if you wanted to abbreviate that, you have a periodic table, you could just do Na. Some of them would be words, and you could figure out the formula. That would be easier than rewriting the words, or you can write them smaller. I'm going to make you do some practice now, so if you please reach out if you don't understand what I'm talking about. I'm going to try to do different formats of videos because this one was very hard to make with this whiteboard, but we will see.